Okay, now we're going. When we wanted to program originally, we would do something like this, N100. So we put an N number at the tool change line. And why we would do that is because we could search. So you knew tool 1 or tool 5 was at line 500, 600, whatever. Or you could go, well, see, I've gone through 5 different tools, N500 search, and it would go down to N500, and you knew that was about your 5th operation. It wasn't necessarily tool 5, but it was your 5th operation. So that could help you, because sometimes we ran programs that were 20, 30 pages of paper, printed paper long. So, I mean, they were this thick as far, so you were like really scrolling through lots of stuff. So we would do that. You can definitely line number every single line if you want to do that. And, you know, on older machines, it does matter for sequence restart. If you want to start them in the middle of the program, on these machines, newer machines, it doesn't matter. You go down as long as your parameter to start in the middle of the program is on, then you can always start in the middle of the program. You can start wherever you want to in a program, as long as the setting is on. So here you can have this or not, M6, T1. It doesn't matter which direction that you put those in. You can do T1, M6, M6, T1. Doesn't make any difference. Now, some machines it will, like that horizontal. Once we get that fired up, I won't be surprised if it matters the orientation of how those go. So sometimes machines would be like this. They would say tool 1, then M6, because it reads in individual codes. It needs tool 1 to come up, then change tools. Newer machines read in sentences. So now it sees M6 tool 1, it means change to tool 1. So it's reading it like a whole sentence rather than operation, 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 operation. So newer controls they're just a lot smarter. All right, we switched tool 1 to tool 2, so I'm going to put that in as tool 2. What I need to make sure that I do is I change my H value on that to 2. H, T, and D need to match. So T and H have to be the same. And then in using cutter compensation, you guys have already done a little bit of it already, then your D on your cutter compensation needs to match the tool as well. Those things need to match. On, let's see, the new Mazax, you don't even have to put any of this. You don't have to put G43 or H2 when it sees the tool. It assumes that you're doing all those things. You don't have to put the D, you don't have to put the G43. It just knows, oh, this is the tool you're using. Surely you're using this length offset too. So it's pretty nice. All right, so 3-inch shell mill. We're gonna face the top of this part. So that means stock is Z0, and that's what it says. So we'll turn our spindle on to 1018, and G43, it's going to start at X of 3.3, Y0. So that means it's starting over here, right? Middle of the part 0. It's then going to face mill across this way eventually. So it's going to be at 1 inch. It's going to go down to 100 thousandths, feeding at 25 inches per minute. And it's going to turn to coolant on. If I have a G1, I've got to have a feed rate. Or I've got to have a feed rate close to it. I can have G1s after this. They will default to the same feed rate. But anytime I need to change it, I need to make sure I get that change put in there. You can't start it with no feed rate, though. It'll just say no feed rate. So I'm going to go down 50 thousandths on the face. I'm going to go across it. You can see my feed rate changes to 60 inches per minute. And then I'm going to get to here. This is a typo. This is a problem that you guys experienced yesterday. What's that? That's not a 0, is it? No. What's the machine going to think when you do that? Well, it's going, you're talking about in motion. It would definitely read past this and do its next thing that it needs to do. But it believes that you're putting in a new program number here. So like yours went to 00000 all the way across it like that, and then it was like all janky. It believes right now that you're starting a new program. So Those,
By one mistake.
by one mistake. But think about it, I mean, it's that, you know, one mistake is a huge deal. I mean, whether you get anesthesia or cough syrup right before your surgery, it's just one mistake, right? You know, but it does matter. So you gotta have those zeros in there. So typos happen all the time. That's why it's super important to run graphics check before you run your part. If you don't hit edit cycle start or graphics, setting graphics, and then cycle start in memory, you're just Russian roulette on doing that. So I would not get myself in the habit of doing that. Okay, so we've went across the part. See, if you look, there's symmetry here. Positive 3.3, negative 3.3. It's easy math to do, and I am a person who likes things that are symmetrical. Positive to negative, same numbers. If this starts out too far and I don't like it, and I want to move it into 3, then I know I move this to negative 3. If it's still too far away, I move it to 2.5, then I move it to negative 2.5. That way I know that my tool is getting across there the entire time.
Right.
Then I'm do a move in rapid. G1 is modal. That means it stays that way until it's changed. I will say that word modal 100,000 times. And then when I ask you what it is, you'll be like, I don't know, I've never heard you say it. So modal, am I right? I've said it, I said it 3 times like yesterday, man. And so modal means that it stays that way until it's changed. It's just like when you hit drive in your car. It's going to stay in drive until you change it to something different. So G1, modal command, stays that way until it's changed. You can see it's changed here by the G0, rapid move. Rapid move cancels out any feed rates or anything like that, brings it to 1 inch. M5 shuts the spindle off. This move right here is reading a full sentence. Incrementally go home to Z0. That brings the spindle all the way up. Okay, there's a couple of different ways that you can do that. You can do, I'll just show you. This is one way to do it. Another way to do it is to do this. This will then raise the spindle all the way up and then bring the table all the way towards you. Another way to do it without having to do this, because this right here can be dangerous because you're actually putting the machine into incremental movements. Incremental means no longer is it go, this is just positive 3 and this is negative 3, but it automatically turns the spot that you're at into 0, and then your next move is then like positive or negative. So here we have 0 right here. If you switch to incremental, then and you move your tool to here, then this becomes 0, then this becomes 0, then this becomes 0. So each one of those places becomes 0. So that could be a problem. When you pair these two commands together, 98 and 20, 91 and 28, then they form a sentence that say, bring the spindle all the way up, bring the table all the way forward. There's another way that you can do it that's a little safer. And do a G53. Actually, on this one, I would probably just do the G53 Z0. There's no need to bring the table back towards me. And then I don't need this G90. If you use the G28, G91, you turn it into incremental, you got to turn it back to absolute. You got to have the G28, G28, G91, then a G90 afterwards. This one will move the spindle all the way up to the top in one line, but it will not move the table towards you. But you don't need the table moved towards you because you don't need to move to you at every single operation. In 01, optional stop. So you do that in your first operation, you don't need to anymore. All right, so this is now tool number 2. This is H value is 2. Now let's move to here. I'm going to take out some of these.
Justin?
Yes,
All of our quarter-inch mills are 2 flute, right?
they are. Okay, you don't have to have dashes here, or spaces. You can if you want to, it doesn't hurt anything. So I'll go ahead and do in 200, just so we have, a designation for our next setup, okay? Again, space here doesn't hurt anything. As you're trying to build a format, then totally it's fine to do that. Same thing here, if you can see this better by spacing these apart, they're not spaced apart here. If this works better for you, go ahead and do that. It's not gonna change how the machine runs at all. So here's how I do it. I don't put any spaces in between my stuff. But if you need to do that until you get the hang of it, then go ahead and do it. It does take milliseconds again to run, but it's not enough to change anything. I'm gonna shove this over just a little bit.
Hey, Justin?
Yep.
So if I'm like, drilling down with that, like a 1/4 inch end mill, like hack drilling, slow, would I calculate like the speed of sitting at SFN with 600 for high speed steel and 300 for what you would drill on a windmill? Because like drills, you calculate 300 times 4 divided by drill. Would I do that for the end mill if I intend to drill?
I would run it, no, I'd run it like a drill.
Run it like a drill.
Yeah, run it like a drill. Yeah, because you're really,
Spin it like a drill or spin it like a 1/4 inch?
I think I
So
could,
the difference of like,
yeah, I think I would be okay with spinning it faster. But I would treat it, yeah, because what you're doing, depending on how deep you get into the hole, you've got a lot of mass and not as easily as it is to eject the chip out of there.
yeah, I figured it explodes, you know, how fast.
Yeah, it could still spin at its normal RPM. Okay, so here we switched to tool 3. Is that all I need to switch to make that tool 3? Switch the H, good job. So my H needs to change to 3. And then here I have cutter comp, and it'll need to switch to 3 as well. Okay, so this is rapid move, inch input, cutter compensation cancel can cycle, absolute. Tool chain, start spindle, 3100 for RPM. G54, this is where it's going to start. Then it's going to go to 1 inch. It's going to go to 100 feet at 25 inches. It's going to go down 200 into the part, and then it's going to go down 500 into the part. Okay, so it's got to go down 500 because we took 50 off the top, right? Once my Z moves have been completed, I then turn cutter compensation on. I don't want you to move cutter compensation. I don't want you to move in Z values when cutter compensation's on. It has a tendency to trick it into, or not trick it, it has a tendency to manipulate it into adding or subtracting cutter compensation diameter into length. It's always safer to just not run in Z. So move where you want, down, turn cutter compensation on, turn cutter compensation off, raise up, move away. Okay, so cutter compensation should only happen after your final Z moves are put in place. All right, X0, Y0, so tell me, X0, Y0 is in the middle of the part, so tell me where the part is going to start at. Negative 2.25, Y minus 1.75, where is that on the part?
Would it be on the left side?
It's all on the left side, upper left side or lower left side? Lower left side, yep. So let's just say it's about right here. Okay. So we've switched to the 3/4 inch, 3 fluid end mill. We've done speeds and feeds for it. We're going to start right here. We're going to feed this way to Y 0.75. Okay, that's the bottom of the part. Then we are going to feed to X 1.25. So that's the middle, or that's the edge of this part, right? So we're coming up, okay. so we went over here. To about, must have went to about here. And then, let me take a second here and associate myself with this thing. X of 2.25 is way over here. Y of negative 1.75. And then I'm gonna go X of negative 1.25, which would be lined up with here. And then I'm gonna go up to Y of 0.75. Okay, I'm with it now. So it's starting over here, it's gonna go up over this way then. To 1.25. Sorry, it's gonna go over here, it's gonna go up this side, it's gonna go over, it's gonna go down this side, it's gonna go over this way, and then down this way, okay? Starting over here, coming up this side, going around this way, okay? So once it's set up like that, once cutter comp is turned on and it's moved the radius of the cutter, then it can go all the way around it to just print dimensions, okay? And then G40 moves it away in Y and then turns coolant off. M5 turns spindle off. And then you can leave this if you want to. G91, G28, then G28, G49, and then G90, absolute programming, then M01. Okay. So that'll then take care of milling around the outside of that part. And then next, get some of this gapping out of here. Tool 4 is our center drill for our engraving. So tool 4, H4, and then we're going to do some engraving. Here are your parameters for engraving. You guys remember how to do some engraving?
No.
So G47 turns your engraving on. So what it's doing here is it's going to the middle of the part. Okay, so right there where the hand is, it's going to the middle of the part. Right now, it's going to do what's in parentheses is what it's going to engrave, EC. Okay, so you're going to, this is where it's going to start, and so actually it'd be over here. Where the hand is. It's gonna start there, it's gonna feed at this, and it's going to give you a 1/2 inch letter. It's going to do a retractor rapid plane at 100 thousandths. Incremental movements, incremental rapid movements that are not in the lettering is going to move at 40 inches a minute. Incremental feed moves that are not in the cut are 40. And then the Z depth is 65 thousandths. So if you want to put, in there. Now it's going to do that. Okay. So you need to play around a little bit with depth and with placement of where that's going to be. So let's try to center it up the best that we can. So, so you should put your first name, last initial, or first initial, last name. So, you know, so you can do
Like J Harbath or J H.
exactly. Either one of those is fine. I'd like to see it as centered up as possible on there. Okay. Now this one I think is good. This is a place where I would definitely do this. G91, spindle goes all the way up. G91Y0, table goes all the way forward, goes back to absolute, into program, percent sign. Okay, that's all that one is. All right, I'm gonna save this into the module, and then you can go ahead and,
Fumble with it just for a bit.
yeah, play with this one a little bit, and then, let's see.
Cause I usually thought that you had to do this and that just to engrave your name, but it's just that simple, just put your name just right there. I usually thought it was more complex. I hope it's not that complex.
So let's take this one, let me look in here at the next. Oh.
Justin, do you know off the top of your head how many flutes our 3/8 hymnals have?
I think we have 2s and 4s. Okay, this is a different part. I want you to work on the part that we just did first. And then while you're doing that, go ahead and let's cut. So I want you to cut 1 by 2 by 3 for the part that we are doing. And then I want you to go ahead and cut some 1 by 2 by 3 for this part as well. Okay, so go ahead and saw yourself parts for the rest of what we're gonna do in this. So this will be programming G41 and G42. So go ahead and saw a couple parts. If it were me, I would saw myself 3 1 by 2 by 3 blocks. That way you've got a mess up. Okay. I'm gonna take and put this program in, the program that we just modified, I'm gonna put it in Canvas, and then you can pull it out of there.